Hey, what's up, everybody? It's Chris here. So today, just a quick video for you. I put together a small repo that basically is just going to help us do something super cool, which is run the new text-to-video model. So this is basically just a NVIDIA runtime that we can use to run this quickly and effectively on our local machine or wherever you want to run it. Can't wait to get into it and see what we can do. So I'm going to go ahead and show you how we can get this thing running and then show you what it can do, which is probably the coolest part. Okay, so first thing we need to do is head over to our terminal. Okay, so I've given the repo a very long name, so I'm going to go ahead and just for the sake of my terminal not filling up, just clone this into the directory text-to-vid. Go ahead and do that. Once we have that done, we can cd into text-to-vid. And now that we're here, we can check out what's inside. So we have our app directory, our Docker file, README, and some requirements. And that's all we need to get started. So 2 things you want to make sure you have done before you go into this. Number 1, you'll have to make sure that you have Docker installed. Number 2, you'll have to make sure that you have the NVIDIA runtime for Docker installed. I'll leave links in the description for how you might be able to do that. It's going to be different depending on your operating system, but essentially as long as you have Docker installed and you have the NVIDIA runtime installed, you're going to be good to go. One quick note too, you're going to need to have a fairly new graphics card, so 3090, 90 Ti, or 4090. And that's because this is going to take up a lot of memory in our GPU, so you have to make sure you have that memory available. But you can spin up an instance on Amazon or whatever you'd like and play around with it there. So we will go ahead and get this going. So the first thing we're going to do is build the image. We're going to use the command docker build-t text-to-vid-demo dot for our present working directory, since the Docker file is in our current working directory. Press enter there. Now, as you can see, I have this cached, so it was rather quick. So once you have the image built, you can use this command docker images pipe grep text-to-vid-demo, and that's going to let us see that it's there. It's going to give us the hash. We're going to see when we last built it, and we're going to see how much space it's taking up. So as you can see, this is fairly large. Now that we have the actual image built, let's go ahead and run this next command, which is going to be our run command. Now, the run command basically is the same as the run command that we used for Alpaca LoRa, which is we want to use docker run --GPUs all. This is to indicate that this is a GPU runtime, and we're going to give it access to all of our GPUs, in my case, just one. We're going to associate this volume with our cache. This is so if we want to re-spin up the container, we don't have to re-download all of the model files, since they are, again, fairly large. We want to address this -p, so this is just going to expose the Gradio ports so that we can access them from the outside, and we want to ensure that we have some additional shared memory so that we can just make sure everything's running smoothly. We're going to run this in interactive terminal mode, and we're going to use the --rm flag to remove this container whenever it is stopped. And all that's left to do is point it at the image we want, which is this text-to-vid demo image. And once we've done that, we can go ahead and run that. Okay, and we can see that it is now running on this IP address. Let's head over to our other screen here and take a peek. We will reload this, and we can see now we have this Gradio demo. So let's see what this thing can do. First things first. This is like basically unsanitized, so you're going to see some outputs that aren't necessarily exactly in line with what you wanted. There is absolutely some bias with this model based on the training data that they used, but let's just see what it can do. The example that they use on the repo is a panda eating bamboo, so I figured why not? Let's give it a shot. So once you have your prompt typed in, you can go ahead and just press generate video. If we navigate to the terminal, we can see this running, and we can see that it's doing 25 iterations. When we pop back to our Gradio app, we will see it's generated something, and let's just give it a play. I mean, it is what it says on the tin. That's a panda. That panda is eating bamboo. Is it a little bit cursed? It sure is a little bit cursed. But what can you expect, right? We're running this off of just a single GPU, so relatively small model, and it performed swimmingly. So there is a few options we can play around with. Number one, we can set a specific seed. If we set the seed to -1, a random seed will be selected. We can indicate the number of frames we want to generate. So let's say we wanted to generate 32 frames instead of 16 frames. And also we can tell the model how long we want it to run inference on this image. So I'm going to put that up to the max just to see what happens. And let's set a seed so we have a better comparison. We'll use the classic 42. And I will go ahead and generate the video and be back when it's done. Okay, and we're done. So let's check out and see what changing some of those parameters wound up doing for us. So as you can see, this is I would say this panda is less cursed, for sure. It behaves more like a panda, and there's a bit more consistency between the frames, though it seems we've lost the eating bamboo aspect of things. So we'll use the same seed, and we'll really reduce the number of inference steps here down to 20, same number of frames, and we'll see what the difference is. Okay, so here's the video with those 20 inference steps. And as you can see, there's a bit less consistency between the frames, but that's fine. The video is actually quite long, and this panda is relatively, I would say, low on the cursed scale, so that's awesome. Let's try another example and see if it can handle it. Okay, so I tried something a little bit more complicated, which was a UFO flying around the desert. Now, I was kind of hopeful that it would like make the ground or something a cake or whatever, or cookies and this and that. But what we wound up with was this is identifiable to me as a UFO flying around. It does kind of look more like a desert. And you'll notice as well that we have this absolutely lovely Shutterstock watermark, which is a relic of the training set. We'll do one more prompt, and then that'll be all. Okay, so this time I gave it the prompt of a seagull flying near a beach. So it's mostly just a seagull-shaped object flying near what definitely can be water, but I'd say not so bad. So let's see what happens when we reduce the number of inference steps from 50 to 25. As you can see, not much difference in the final output. So, if you found this interesting, you can go ahead and click the like button or subscribe. And if you wind up running this and, creating some images, I'd love to see what you guys are doing. So I'll leave a link to the repository in the description, as well as some links explaining how to, again, install Docker or the NVIDIA runtime. So thanks so much for your time. Hope you have a great day, and we'll see you in the next one.